And also, I have a bunch of requests because this I got these for just crazy. No. But he does pretty good. Oh yeah, easily.
All right, happy Thursday. How's everyone doing? Well, good to see all of you. Isn't this adorable? Look at that smile. So we have a big one today. We are wrapping up part one. The way class is going to run today, it'll feel a little bit different. We're going to get through the rest of part 1.5 in sort of our normal way. So we'll talk through scatter plots, bivariate numerical variables, and then we'll do time series, so bivariate time series. And we're going to do both of those basically back to back in part 1.5. But then when we start talking about geographic variables, geographic data is a bit harder to work with in general. So what I want to do with 1.6, I just want to show you a bit of an example of how to work with geographic data. We'll talk a bit about it, and then I've posted homework 1.6, which is technically due tomorrow, but we're going to do it in class. There are like 4 questions, and we're just going to, this is my little gift to you right before the mini exam, we're just going to do it together. So that's what we're going to do. I don't want you to be trying to scramble putting homework 1.6 together on your own. If we don't get it done in class, then I'm not going to have it due. So we're only going to do it if we can get through it in class. And then I have a couple of sort of wrap-up exercises for us at the very end of class. So I'm hoping we have maybe 20 minutes to spend just talking about what we've covered in part 1 before we end part 1. And I think this will be a pretty good indication of the kinds of questions you'll see on the mini exam. So in some ways, we're going to save the last 20 minutes essentially as mini exam kind of prep. This is in addition to the mini exam demo that I'll post in the next couple of days. I'll send out an announcement once that's up. But I think in total, this should give you a pretty good sense of what to expect on the mini exam. Any questions about that? That's where we're going. You should have almost all of your homework back. I think I still have 1 more to grade. As always, you can hit the regrade request. I think sometimes there are some questions where Gradescope isn't so good at knowing what's true and what's not. So if you, I think some people put in countries after a number, and that gave you 0 points. If your number's right, just hit regrade request, and I'll see it, and I'll give you points for that. Let's see, any other housekeeping? Well, great. Nice seeing all of you twice a week. Some of you is 3 times a week, and I love that, on Wednesdays for office hours. Unfortunately, Maxine has not been to office hours, although she has been to the department. Make sure you're getting your top hat. So just as a reminder of where we've been, last class we were talking about bivariate relationships. We talked about this kind of situation where we have 2 variables and we're interested in their relationship. So we talked about how you can have multiple histograms which give you separate summaries of the two variables separately. But sometimes we care about the relationships. So one question you might have is whether the GDP is related to coffee production for a country. So this is cross-sectional data. We talked about this data set, introduced it last time. And you might wonder, do countries with higher GDP produce more coffee? Which is a question you may be interested in. And I think that your homework has a similar kind of question. From a relationship perspective, right, 2 histograms doesn't give us a very good picture of whether these 2 variables are related. It summarizes both of them separately, but it doesn't give us a relationship picture. So we talked about one potential here would be with a line graph. We talked about how a line graph, when we're thinking about cross-sectional data, is not very informative. It's sort of misleading, indicating to us that the countries themselves are related, which is not true. And in some ways, it sort of obscures the data points themselves. So what we did is we talked about, we used a scatter plot to show the horizontal axis being GDP, and then the vertical axis being coffee production. So this is essentially where we left off last time. We walked through, reading scatter plots like this, and we asked, a series of sub-questions. So one of them could be, which countries have a GDP above $2 trillion? And, the way we read this, someone should add WD-40 to these chairs and the doors. $2 trillion, we just look at the horizontal axis and just find all of the points that are above 2 trillion, as you'd expect. We can also do this on the vertical axis, so these sort of slicing decisions can happen on either axis, which is part of the power of a scatter plot. So we said, how many countries are above 1/2 billion kilograms in production of coffee? And we can just identify that with a horizontal line at 1/2. This is where you told me that my figure was not that useful because I didn't have the half, and I still haven't fixed it. So send all your complaints to hatemail@econ.org. So then one thing we can also do with a scatter plot, a big part of the power of these things, which is, we're going to use these repeatedly all semester. We can look at the relationships between points. And I ask a couple of questions about this on your homework. So one question we could ask is whether, which countries in this data set produce less coffee per dollar than Brazil. So we said coffee per dollar is a ratio. So we can look at the point Brazil and then find a separating line running from the origin to Brazil, which gives us a perspective on, coffee per dollar. So this is all of the points that represent the same coffee production per dollar. And then we just walked through and thought about the points, which side of this line has more dollars per coffee production than Brazil. So produce less coffee per dollar than Brazil, so more dollars per coffee. And that turned out to be on the lower end. So the way you can check this is just to look at the figure and then say, is there more dollars for the same level of coffee? Or you can think of, is there less coffee production for the same level of dollars? So you just run a line up until it hits the vertical, or the separating line. So this is how we use these scatter plots to make ratio comparisons. And then we can do the same thing for countries that produce more coffee per dollar than Brazil. And then we walked through a couple of these kinds of questions at the end of class. So this is everyone's on their way out the door, and I asked you rudely a couple of final questions. One of them was, do the GDPs of the upper or lower pair differ by a larger amount? And we're going to use this as just a warm-up question. So you've already answered this, but just tell your neighbor whether the upper pair, so Brazil and Thailand, or the lower pair, Cameroon and Malawi, differ by a larger amount. Just tell your neighbor, maybe also throw in one of the things you're looking forward to doing this weekend. And studying for a mini exam is not on the list.
Friday's supposed to be my free day, man. I'm going home. Well, this didn't think it's fun. Yeah. I'm working on one of the people and their dads.
Okay, someone help me out here. Actually, raise of hands. How many of you think the upper pair differs by a larger amount? And how many of you think the lower pair differs by a larger amount? And then everyone else abstains? I see you. Okay, yeah, it's the upper pair. And it's clearly the upper pair. You can see, if we just look at the horizontal axis, Cameroon and Malawi don't differ by that much in absolute terms. It's even really difficult to see that there's a difference between the two countries. Where for Thailand and Brazil, you can see Brazil is just over, just over $3 trillion in GDP, and then Thailand is a little over 1. So that differs by almost $2 trillion on the horizontal axis. So clearly, Brazil is just, the upper pair differs by a larger amount. What if I asked you this question? Which is larger, the ratio of the GDPs of the upper pair, or the ratio of the GDP of the lower pair? Take a second, talk to your neighbor about this. Maybe, if you didn't tell your neighbor something fun you're doing this weekend, now would be your chance. But I am looking for an answer here. Okay, we have a lot to get through today, so I'm going to cut this shorter than normal. How many of you think the ratio of the upper pair is larger? Okay, I see you. How many of you think the ratio of the lower pair is larger? Okay, maybe slightly more on the lower pair. And how many of you are uncertain? I'm in your group. Looking at this figure, I would not be able to tell which ratio is larger. If you look at, Brazil to Thailand, if you divide Brazil's GDP by Thailand's GDP, that's, I don't know, roughly, it's like right around 3. Where if you look at Cameroon and Malawi, it's very difficult to tell what this ratio is. So it's difficult to be able to make that comparison. Using absolute numbers on the horizontal axis like this, or any axis, gives us a great way of making comparisons of absolute difference, but it makes it very difficult to make ratio interpretations. Anyone know what one alternative way of setting up an axis that might be helpful in this case? Luke? That's it. We're going to use a log scale. So on the horizontal axis, instead of using the actual values with equal ticks representing equal sizes. So you'll notice here we have 0 to 1 is the same difference as 1 to 2. What we're going to do instead is set up a logarithmic scale. And we're going to talk about logarithmic transformations in part 2. So you're going to be able to do this in a couple of weeks. What I'm doing here is setting up a log scale. So instead of having each tick represent an equal distance, each tick is multiplying by 10. So we go from this first tick and we go to the second one. We're increasing GDP by a factor of 10. So we're multiplying by 10 as we go from one tick to the next. And so when we go from a GDP of 0.01 trillion to the next tick at 0.1 trillion, we've multiplied by 10. So each one of these ticks is representing, it's consistent because we're multiplying by the same amount each time, but it's not an equal interval. Because this difference is very small, where going from 1 to 10 is actually an increase of $9 trillion. So this is what we call a logarithmic scale, and it has a number of very nice properties. First, you can already see with our linear scale, it was very difficult to make a comparison between Cameroon and Malawi. You couldn't see the small differences. When we go to a logarithmic scale, here you actually can see the differences. So one of the things that logarithmic scales do is they separate clumped data while leaving separation between the larger values. So in this case, we can still see that there's some difference between Brazil and Thailand, but we can also see that there's a difference between Cameroon and Malawi. But the second thing a logarithmic scale does is allow us to make ratio comparisons. So here we can see as we go from this tick to this tick, we're increasing by a factor of 10. We're multiplying by 10. So if there was a point on 0.01 and a point on 0.1, we would know that the ratio of those two values was 10. And then the same thing for each one of these ticks. So the difference on the horizontal axis represents the scaling value, like what the ratio is. The horizontal difference represents the ratio. Okay, so in this case, with a logarithmic scale, I want you to try to answer this question a second time. Is the ratio of the GDPs of the upper or lower pairs greater? Truly take a shot at this. You got it?
I think so.
Okay. I won't call on you, don't worry.
No.
Let's see. I don't mean to ignore you while I look this way. Let's see. Your name is Matt?
Yes.
Is it Chase?
Yeah, it is.
Okay. I'm not going to call you.
I was in your microeconomics class last year.
The big one? Okay. Let's see. Fall of 2023. So you're, let's see, a junior. Okay. That was a fun class.
That was a fun class.
Yeah, I loved that one. Yeah, that's the problem with this big classes. Some people answer my questions in those classes, and I would not have been that person.
Yeah, I'm not getting a little bit right. I sit in the middle, trying my nose to get out.
Yeah. Were you in that class too?
Oh, no.
No, okay. It's Matt and Chase. I'll get your names eventually. I'm not ignoring you. Okay, so someone tell me. Actually, let's get a raise of hands. How many of you think it's the upper pair? A larger difference, a larger ratio. And how many of you think it's the lower pair? And how many of you think it's unclear? Okay, so it's much clearer looking at ratios using a log scale. And that's for two reasons. One, because we're able to separate small differences. And two, the log scale inherently allows us to make multiplicative comparisons. You all know like decibels, like the measure of sound. As you go from 60 decibels to 70 decibels, you're actually doubling the level of sound. Decibels are on a log scale. Also, the Richter scale, the way we measure earthquakes, that's also a logarithmic scale. So as you go from like, was it 4 to 5? I think that's a reasonable measure of an earthquake. I believe that's a doubling of the force of an earthquake. These are logarithmic scales, and we use them for good reason. It makes it easy to make comparisons and also be able to distinguish between very large and very small values. We're not going to actually do these logarithmic transformations in part 1.5. We will I believe it's in part 2.2, so we'll get there eventually. Okay, so we can also ask questions on the vertical axis. So we could ask questions about the second highest output of coffee, and I have some slides here you could take a look at. I don't want to spend so much time on this. We have a lot to get through today, but I have some sub-questions that are good to walk through. So which country produces the second highest amount of coffee? Well, we could do this in a linear scale, just like we did on the horizontal axis. But if you're asking about the second highest amount of coffee, well, Brazil definitely produces the most coffee. But just like on the horizontal axis, when we were making comparisons between Malawi and Cameroon, because the values are so small, a linear scale makes it difficult to see any sort of variation. So just like with the horizontal axis, the vertical axis, when there are these, it's difficult to know which one of these three countries is producing the second highest amount of coffee. So we can apply a logarithmic transformation to the vertical axis. And this is what we call a log-log scale, where both axes are in logarithms. And here, it's much easier to see these scaling relationships. We no longer have clumping on the vertical axis or on the horizontal axis. We've actually separated values, both large and small. So when we're talking about differences between countries, often these kinds of relationships are just much easier to see in a log scale, or in this case, a log-log scale. Okay, so the second highest coffee production is Cameroon. Any questions here? A lot of you will probably use log scales in your final project. This is a very common transformation, and it's really not that challenging to do. I'll show you one line how to do that in part 2. Okay, so we can see both large and small. One thing we also might ask, and here, it looks like coffee production is related to GDP, at least for the countries we're looking at. But in addition to the overall pattern with all of the countries we're looking at, we could also just identify subsets of our data. We're going to talk about, this is sort of previewing a bit of part 2. In addition to making transformations of variables, we can also perform subsets. So we can look at subsets of our data and ask, it looks like there's a positive relationship for all of the countries, but is it true for the Americas? So what I'm going to do is take a subset by filtering countries based on their location. So are you in the Americas? And if you are, I'm going to plot those countries. And we're in a log-log scale still, which is nice. And we've performed a subset, which gives us a better picture for which countries are which. And we can see relationships between the variables of a subset. And we've done this through filtering. So this is just to give you a picture of what we're going to be working with in part 2, some of these kinds of operations on data. Okay, and looks like there's a relationship here, but we're going to formally test these kinds of relationships in part 4. Okay, any questions? Clear as mud. Love that. And then a couple of final questions here, but I don't really want to take the time to walk through this today. All right, so a bit of a summary here. Relationships between two variables, especially when they're numerical variables like this, are best shown with scatter plots. I think scatter plots are just, in some sense, should be your default when you're thinking about visualizing data. It makes it very easy to see relatively complex things. And as we'll do later, we can actually filter very easily with a scatter plot. And then We can make absolute comparisons on either axis using a linear scale, but often when we're talking about things like countries, where very large countries are very unusual and very small countries are much more common, then we actually want something more like a log scale. So we can see small differences and large differences at the same time, which also makes it easy to make ratio comparisons. Okay, so our first exercise for today is to create these cross-sectional scatter plots. And I have a nice little data set for us. So we're going to do 2 exercises in this notebook. You can just hop over to the course page and click on the notebook. And if you're interested in doing this in Excel, which we'll start with, you can download the Beans and GDP dataset. So as always, my little mini lecture to you, keep your data organized. Have I said that before? I don't think I have. Have I also told you I just had a child? No, I don't think I've told you that before. So we're going to rename this folder part 1.5. And then we're just going to go to our downloads folder. We've just downloaded the Beans GDP dataset. I'm just going to drag that over. Almost dragged over my picture of my daughter. And then once we open this, you can see what we're working with. I'm going to hit Save As, which will save the Excel version of this. And then we can just take a look. All right, so what we have here, we have the country code, we have the year. So this is just one particular year. So is this cross-sectional? Is this time series, or is it panel? Maybe tell your neighbor. How many of you think it's cross-sectional? How many of you think it's time series? And how many of you think it's panel? We have one point in time represented in our data. There's no time variation. Even though there's a year column, we only see each country appearing once. So this is cross-sectional. If we had multiple years, that would be panel. So we have a year column that, in theory, we could have multiple years and each country appearing multiple times. But the data set as it exists here, even though there's a year column, is still cross-sectional. So we're saying which year we're taking the cross-section, but it's not repeated measures of the entity. Any questions there? Okay, so this is cross-section. We also have coffee production, so this is a measure of output, and then this is the GDP for the country. So we have bivariate data, right? We have 2 variables that we're interested in cross-section. So in this case, one thing we might be interested in is plotting GDP against coffee production. Anyone know what we might do here to create a figure? We've done some scatter plots already. Let's select our data, and I'm going to select these. I'm going to go into Insert and then Scatter Plot, and then we have our scatter plot here. Okay, so if you wanted to be a little bit better about these things, you can go in and just check which x and y values correspond with which variables. So here we have column D representing the x variable. So our horizontal axis is coffee production, and our vertical axis is GDP. So you could switch these if you like. For our purposes today, this is pretty good. I'm going to add an axis title. So our horizontal will be coffee production. And then our vertical axis will be GDP. And then we can rename this. So this is coffee production and GDP in 2019. Okay, any questions about this? We've made nice scatter plots before. We've used scatter plots to look at panel data. So we've looked at changes through time, but we can also look at bivariate cross-sectional relationships using scatter plots. So two different data structures with the same tool. All right, so this is nice. Anyone think it'll be easier in Python? Always is, yeah. That's the answer I'm looking for. You can disagree with that, and good people do, but I don't. So you can click on the notebook, as I might do on Netflix this weekend. Okay, I haven't used that joke in a while. Wasn't funny the first time, wasn't funny the second time. So I'm just going to load the notebook here. We have exercise 1.5. I'm going to load the first data set, and we'll just take a look at this. So this is GDP, and we'll plot this out. So like we did before, we have country code, we have the year, and we can see this is still just 2019. We have our copy production, we have our entity, and we have the GDP. So what I'm going to do is just, well, first, if you had to guess, what would the line of code look like? Someone want to take the guess for me? We've done a scatter plot before. What do we start with? Yeah. SNS.scatterplot. And then what comes next? Someone else? Yeah. Okay, so the data we're about to use. So in this case, that's GDP. And then what's next? Yeah, Hannah. Y is equal to coffee production. If we run this, we get our nice scatter plot. And Seaborn automatically labels things for us. We can also add a label. It's interesting. I was looking through some of your code. Some of you took screenshots of your output and your code when you submitted. You don't need to do that. But I noticed, actually, I learned something from your homework. If we want to set the title, we can just hit set, and then title is equal to coffee production and GDP in 2019. So there actually is a way of setting the title with Seaborn. So if you run this, it'll give you a title. I didn't know that before yesterday when I graded your homework. That's amazing. I grade anonymously, so I don't actually know who it was, unfortunately. But if you don't want to do it this way, you can, I'm just going to comment that out. You could do plt.title is equal to copy production and GDP. So either way you do it, it comes out the same. This is my standard way of doing it, but you're more than welcome to do whatever you like. Okay, any questions here? Let's add a grid maybe. Some people like grids, some people don't. Okay, nice scatter plot. This is cross-sectional bivariate data. We have two variables that we're interested in, and it's in cross-section. We used scatter plots for panel data. So we used 2 different years and plotted those years against each other, which was a very appropriate use of a scatter plot. We have bivariate cross-sectional numerical data. So it's numerical, so we can plot it on a horizontal axis. It's cross-sectional, there's only 1 year, and it's bivariate. We have 2 numerical variables. But in addition to doing data in cross-section, we also can work with bivariate time series data. So we have a second data set. This one is coffee prices and oil prices. So we have the price of oil, it's like per cubic meter. And then we also have the coffee price per pound. And this is green beans, so before it's been processed. Okay, and you can see the data set. You can see the data set here. So if we download this, you can take a look. We have the year, we have the coffee price, and we have the oil price. So someone turn to your neighbor, tell your neighbor what the data structure is, and then what are the variable types for the main data. Variable types and data structure. Okay, nice. Is this univariate or multivariate? Hands up for univariate. Hands up for multivariate. Okay. And technically this is bivariate. We have 2 variables of interest. Is this time series, panel, or cross-section? Hands up for time series. Hands up for panel. Hands up for cross-section. This is time series. We have we have 2 columns that we're measuring, but we're measuring, we don't have repeated entities through time. It's just one entity. Questions about this? We have 2 variables that we're tracking through time. We don't have more than one entity. Right, so we're measuring, we don't have like multiple, we do have multiple lines we can draw. So it's, we can draw multiple lines, but it's not, we're not measuring, the coffee price in the US and the coffee price in Europe over this time. There aren't multiple countries, multiple households, multiple individuals. Yeah, Sabi.
So if, like for the year 2001, if we had multiple values of coffee and oil, then that would make it a panel data?
Yeah, so if we were tracking, let's say, the coffee price in Europe, the oil price in Europe, and the coffee price and oil price in the US, we'd have two entities that we'd be measuring through time. Yeah. Okay. Any questions here? Bivariate time series data. In this case, we have time you could think of as being on the horizontal axis, and we have 2 variables. So one question you might ask is whether there's a relationship between these 2 commodity prices. So if you're looking at this graph, what do you see? Someone describe this, the relationship that you would see. We're simply taking both series and plotting them on the same graph. And what does this tell us? Yeah, Alexis.
But because of the scale, because oil is very expensive and coffee is not relative to oil, coffee looks like it's close to zero, oil looks like it's,
Yeah, so scale on the vertical axis, we're using the same axis for both series. Because oil just has a larger price, we can see the fluctuation in the price of oil, but we can't see the fluctuation in the price of coffee. So it just looks like a horizontal flat line at zero, basically. How many of you think this is informative for our question, which is there a relationship between coffee and oil? Lots of people saying no. You're correct. I often give you the bad figure first. What do you think we could do? What if we use different scales? This is what we call a twin plot. I'm not going to ask you to make one of these, but this is one thing we can do. So we have so we have two series, right? We can use different scales for each of the two series. So we could plot coffee price in blue with one scale, and then oil price in orange in a different scale. And because we're using two different scales, we can then essentially zoom in on the time series of coffee to get the variation in the two values. Okay, this is what we call a twin plot. My wife is a triplet, so I'm very fond of these. They're a little bit more challenging to produce in both Excel and Seaborn, so we're not going to do it in class. It's not part of the exercise. One follow-up question I might ask, once we have this twin plot, is there a relationship between the two prices? Like, do they move in the same direction or do they move in opposite directions? And one thing you can do to answer that question is use shading, like we've done. It's a little bit challenging to see it just from this figure. I'm sorry I'm moving a little bit quick today. We have some bigger stuff I want to get to a little bit later. So we can use shading just to check when the two prices move in opposite directions. So you can see here coffee price came down and oil price went up. Here oil price went up and coffee price came down. And so all I've done is just shaded the different regions, the different years by whether they're moving in opposite directions. So time series with a twin plot like this can give us like a nice picture, and then we can shade to try to answer our question. But we're talking about bivariate relationships, and you may have realized we could also do this with a scatter plot. So just like we talk about changes through time with in panel using a scatter plot, we can just take the individual values of price and of the two prices and plot them with price of oil on the horizontal axis and price of coffee on the vertical axis, or the other way around. I think to answer the question at hand, which is, are the two prices positively or negatively related to each other, it's difficult to answer with a multi-line plot. So what I've done here is plotted coffee price on the horizontal axis and oil price on the vertical axis. And I think, as is often the case, scatter plots, if you can use them effectively, give you a very nice view of your data. So here, I think we took a nearly impossible question with a multi-line graph. Are the two prices related? Maybe you could just look at the different increases and decreases with the two series. But it's very difficult to answer the question at hand, the relationship between prices, using a multi-line plot, where once I place each individual point on a scatter plot, the relationship becomes much easier to understand. I'd call this positive. Anyone disagree? Good. Good students. Okay, so nice. So we can use a scatter plot for panel. We can use a scatter plot for bivariate cross-section. We can also use a scatter plot for bivariate time series. So let's do this one more time. We'll do one more exercise, and then we're going to turn to some sub-questions. Okay, so, well, last question for you. Is this telling us that the price of oil determines the price of coffee? Why not, Luke?
Correlation doesn't equal causation.
So correlation doesn't equal causation. You've probably heard this a million times. And we're going to dig into this once we hit part 5. So near the end of the semester, we're actually going to talk in a bit of detail about like you've heard it before, but I'm going to try to convince you of like deeply why it's true. Here, the two prices could be moving together. It could be causation. It could, in theory, be that, right? Like it takes oil to produce coffee, and so maybe the cost of an input makes it harder, more costly to produce coffee. So as the input price goes up, coffee price could follow. But it could also be something else. Just transportation costs, like the cost of putting a bunch of stuff on a large ship and shipping it across the country, across the world. There could be a common cause. So it could be just more difficult to ship internationally, and so that would raise the price of both of these commodities. So it could be a lot of different things. Just simply because we have a positive relationship like this doesn't mean that one is causing the other. Okay, so very nice. The next thing we're going to do is just create a scatter plot of these time series variables. So we've plotted a scatter plot with panel data, 2 different years, plotted those 2 years against each other. We've plotted cross-sectional variation. This was GDP and coffee production. And then the last thing we're going to do is plot time series on a scatter plot. So you all know how this goes. For the sake of time, I'm going to keep this snappy. We have SNS dot scatterplot. What if we hit tab? It doesn't know what's going on. So I'm just going to print out prices. And we have our 2 columns. We have year, which represents each individual year. And all we want is a scatter plot representing a point for each one of these years, with the horizontal axis representing coffee prices and the vertical axis representing the price of oil in that year. So I'm going to have X represent coffee and the horizontal represent oil. And then we'll plot that. So Gemini got it mostly right, but we had to do a little bit of extra. Nice figure, basically 1 line of code, although I added 2 extras to give it a title and a grid. Pretty simple. And this tells us that it does look like there's a relationship between the 2 prices. And in general, this is true for commodities, that the prices of most commodities generally move in the same directions. Any questions? How would you all feel if I skipped homework 1.6? Would that be nice? If you want to take a look at it, I'm deleting the due date, so you don't need to turn it in. But you can take a look at it here. So in part 1.6, you have access to my slides that I'm mostly going to skip. And then we don't have an exercise for part 1.6. We were going to walk through this homework. Essentially what we were going to do is talk about geographic data and then maps and plots and maps. So we have latitude and longitude. I'll talk maybe a bit about it, but I want to spend the rest of class doing some exercises before the mini exam. So you can take a look at this. The due date was supposed to be tomorrow. We're going to do it in class. We don't have the time for that. So you don't need to turn it in. But here's the notebook if you want to actually try. It's pretty interesting. It turns out that you can plot a relationship between the latitude of a city and its temperature. And that homework walks you through. Anyone disappointed to not be covering geographic data in a lot of detail? No? You're saying no? That's the wrong answer. I wrote my dissertation using geographic data, so I'm very fond of it. Let me just tell you a bit about what geographic data looks like. In general, we have, if we're talking about points on a map, we have latitude and longitude. So this is like, latitude is how close you are to the equator, and then longitude is, it's like a measurement of how far around the Earth you are, like what point on the equator. And then altitude is just like how far off the ocean. We usually just look at latitude and longitude, like the data set for the fake homework. And then, like in the homework, we also combine these things with other measures like population. So I have a bunch of cities in the data set, and each city has a population. And there's also average temperature in the data set. So you can take a look at that. So this is all for points. We have more complicated things. You can call them shapes. In these slides, I walk you through a couple examples of how to work with these things. It's more advanced, so I don't really want to spend a lot of meaningful class time on it. But I just wanted to tell you about these things. I had this little example where I took a bunch of restaurants in Pittsburgh and then neighborhoods of Pittsburgh and plotted these things. So this is just, this is exactly the same kind of figure as we've been working with scatter plots. It's like an X variable and a Y variable. And all we do with a map is we just plot a shape on a X and Y coordinate system. So in this case, we have longitude on the horizontal axis and latitude measuring how far north we are. Y'all recognize a map of Pittsburgh. These are shapes. This is a shape. Pittsburgh also has separate zip codes, so I'm right up here. Right now we're right here. So we can get different levels of detail. One of my favorite maps is from the New York Times, which is like a very detailed map of voting precincts and how they voted. Lots of detailed data on those things. And we can use colors to represent different values. So this is just a map of different populations by zip code. You can also make little interactive maps. So this is just a fun little thing you can do. So yeah, we're in this region, and I think this is actually no one lives here. I think this is yeah, there's no housing in this very small area. I think some of you may live here. So yeah, this is just a different way of looking at data, these interactive maps. I think this is fun. I've had students be interested in making these things. I have some code to do it. It's a little more complex than the kind of code I want you to be writing this semester, but it's at least available, which is why I show it. So this is a little sequence I would walk you through if we had more time. But in addition to using shapes, we can also represent points on a map. And essentially, the way Python plots this, it's exactly the same as making a scatter plot. In fact, in the fake homework I give you, you actually create a map simply using a scatter plot, which it's very simple. So we can plot that on a little interactive map. You can see the different restaurants. It's not all. How many of you have eaten here? I did once. Yeah, pretty good. I've only eaten there once. No shade. So we have points, and we have these shapes, and we can do a bunch of stuff to it. This is a very famous economics paper which uses geographic data to talk about the role of institutions. And then my dissertation used voting registration records. I geocoded everyone in North Carolina. So this is just outside Charlotte. You can see this is like a very detailed map, and these are all the different voters in the area. So you can play around with this. And then all I did was look at who their neighbors were, and then check whether people who lived in, if someone moved in next door, did that change their voting behavior? This is a panel data set, so it's a series of each individual voter through time. And it's geographic because I was able to construct someone's neighborhood and look at the changes in their neighborhood. So these are the kinds of things you can do both with panel data. I'm very fond of panel data, and I'm very fond of geographic data. So you can go through the rest of this if you like, just finding whether there's a relationship between distance from downtown and density of restaurants in a zip code. Okay, and it turns out it looks like this. All right, but I want to, this is the homework, we were gonna do this in class. I wildly misestimated how long this would all take. We are nixing this. What I want to spend the rest of class talking about is just where we've been with part 1. I have 9 exercises. None of this will be with code. I'm going to ask you similar questions to what you'll see on a mini exam. And I want you to do this interactively or collaboratively with the people around you. So I'm going to ask you basically 2 questions for each one of these data sets. First off, I want you to describe the data structure, or the dimensions of the data, and then how would you visualize it? Okay, so first one. And we're going to do this for the rest of class. If we don't get through it all, the slides are on the course website. So first question for you. I have this data set. Describe the dimensions of the data. So this is the number of variables. This is the variable type, and then it's the data structure. So those 3 dimensions of data: number of variables, variable type, and data structure. So we'll take about a minute here just to answer this first question, and then we'll talk about visualizing next. I think some of it will be, you'll you'll select, from a list, essentially.
So are some of it, like some are open and then some are?
Yeah, I'm gonna ask you to make a figure, like just either drawing it or just describe to me what it will look like. So that part will not be multiple choice. These kinds of things are, it's like, there's only a certain number of categories. Okay, so is this univariate? Is it bivariate? Is it multivariate? How many of you for univariate? Ooh, commit. Bivariate? Interesting. I would call this univariate. We have the ID. but we usually don't call this a variable. I would call this univariate. Maybe I'll leave ID off, but usually ID is not considered a variable. It's just like a way we keep track of the column. Okay, so univariate, what type of data, or sorry, what's the data structure? Actually, raise of hands for cross-section. Raise of hands for time series. Raise of hands for panel. Okay, people are unwilling to commit. I saw a few hands. If we look, these are the individuals. It's just sort of how we keep track. There's no repetition. So this is cross-section. We're in cross-section, univariate, and what's the variable type? Is it binary? Well, first off, is it categorical or numerical? Category? Numerical? Correct. And then within categorical, is it binary, nominal, or ordinal? Binary? Nominal? Ordinal? Correct. There are two options, at least from what we can see. So given the information here, there may be like a third, which is like uncertain or something like that. But given the information here, this is binary. So cross-sectional, univariate, and binary categorical. Okay. So the second question is how you would visualize this, how you would summarize effectively cross-sectional, binary categorical, univariate data. So we'll take maybe 30 seconds here, chat with someone next to you. All right, someone want to tell me what you would do? Yeah. A bar graph. Yeah. So bar graph is nice. Anyone do anything differently? Savi?
Maybe a pie chart?
Maybe a pie chart. If there is a use of a pie chart, it is with this this data. Binary categorical. Okay. Should we do another one? Exercise 2. So same set of questions. What's the dimensions of data? Number of variables, data structure, and then main variable types.
I should do a paper like that. Maybe if any of you lawyers actually look at it, it's just a bunch of
All right, someone help me out here. Instead of raising hands, someone want to tell me what you answered? Savi?
Categorical, univariate, nominal. Sorry, categorical, nominal, univariate data.
Okay.
Cross-section.
Okay.
And I mean, we only have tech code for like one count, so
Yeah.
maybe like a background.
Okay, so bar graph. So Savi's saying the data structure is cross-section. there's not a lot of information here, but we're not told that there's a repeating entity through time. And it definitely doesn't look like this is time series. So cross-sectional, it's univariate. This case is easier than the last one. We don't have to discard ID. But even if there was ID, we would still call this univariate. And then the variable type, this is nominal. It's definitely categorical. And it's nominal because there's more than 2 categories, and there's no inherent order. Okay, any questions here? And then Sabi's saying bar graph, which is what I would do, bar plot. Okay. And I don't particularly care, like when you answer your mini exam, if you plotted it vertically or horizontally, I don't particularly care about that. I think horizontal bar graphs are just in general better if the title is for each bar is long, because English runs right to left. But smart people can disagree about that. Okay. Matt disagrees. What about this one? Exercise 3. We'll take a minute here. And dimensions of data, summarization type. Okay, someone help me out here. What are we looking at? Yeah. Okay, so definitely, I mean, it looks cross-sectional. It'd be very difficult to hold, well, I guess you can hold a high school degree and a master's degree at the same time, which I do. But yeah, so this is cross-sectional. It's also ordinal, categorical. We know it's ordinal. It's definitely categorical. And we know it's ordinal because we can create an order with degrees, right? Like one generally follows the other. You can skip from high school to master's. It's very unusual. And then, let's see, the last part is univariate. There's only one variable here. So yeah, we definitely call this univariate. Someone else want to tell me how you would summarize this? Jason. So we could do an ordered bar graph. Yeah. The only difference here, the main difference between ordinal and nominal categorical variables is we need to insist on the order of the bars. Sometimes with ordinal categorical data, the categories can be listed as numbers. And in that case, we can use a histogram. So I think like the rankings, the excitement level in the class on one of your homeworks, there's no inherent meaningful difference between the number values. They're not measuring something meaningful, like a count would be. So it's even though it's numerical, it would still be ordinal categorical. And in that case, we could represent like a numerical scale of excitement using a histogram, which would be very similar to a bar chart with an ordered axis. Yeah.
So on the example aspect, just actually the visualization,
Yeah.
would you give us like numbers to
Yeah, so I wouldn't ask you to like fully summarize the numbers in the data set. It would just be a general picture of what a figure would look like. Yeah, without being meaningful necessarily, unless I specify otherwise. I have asked for that kind of thing in the past, but I'll tell you to do that. Yeah. Okay, what else? Should we do another one? I have 9 of these. Exercise 4, annual income. We'll take a minute. Okay, someone help me out. What are we looking at? What's the dimension of the data? Ruby. Okay. Okay. Univariate. Okay. So we're not told anything about. I should have specified like an index here. My intention with this question was to have individual IDs.
So it's not the same person.
Right. So if it was the same person, this could be a time series. Yeah, that's right. But yeah, the intention here was to have it be across individuals. I specify that a little bit. Well, I guess that's also unclear. Hopefully the mini exam will be clearer. Yeah, so this is cross-section, numerical, and univariate. Yeah. Any questions about this? And technically we make a distinction between discrete and continuous. In this case, I would say this is a continuous variable, just like Ruby's saying. But in practice, we generally don't make a big fuss about which is which. In some sense, we're measuring dollars, which are discrete. So I don't make a big fuss about that. So what would we do in this case? Yeah. A box plot. Yeah, so a box plot could work. We would, on the horizontal axis or the vertical axis, we would just specify the quartiles and then maybe add a strip plot to it. Yeah. Sorry, Sophia? Hannah, I'm sorry. So yeah, box plot could work. I think my first response with these kinds of variables is a histogram, but a box plot is equally good. Your preferences can vary. There are multiple correct answers to this one. Okay, should we do one more? The slides are on the website, so feel free to keep going after class. Let's do this last one. Take a minute. This is, I think, the hardest one. Like, we haven't covered this one in a lot of detail. Actually, I don't want to leave you on this one. This one, we haven't really covered it. This is definitely cross-sectional. It's bivariate, categorical by categorical. So these are two categorical variables. So you could classify this, I think. We haven't talked about visualizing this kind of data. So I'm sorry that was the, I include this as an example of something that we haven't covered and I won't ask you about. At least visualizing it. You can definitely classify, but visualizing we haven't talked about. So keep going through these. There are a couple more, and then I'm also going to post a mini exam just so you can see what it looks like. Yes. I'll send out an announcement when that's up. You good, Ruby? You good?